Today we are going to see small sample test. Suppose the samples are drawn from the population with equal variance, we can use F test. The procedure for test of equality of two population variances. First fix the null hypothesis H naught equal to sigma 2 square. The alternative hypothesis sigma 1 squared is not equal to sigma 2 squared. The test statistics, that is F is equal to S1 squared by S2 squared. When S1 squared is greater than S2 squared, where S1 squared equal to N1 by N1 minus 1 into S1 squared, S2 squared equal to N2 by N2 minus 1 into small s2 squared. N1, N2 are the size of the samples drawn from the two population, and S1 squared and S2 squared are the sample variance. The number of degrees of freedom N1 minus 1, N2 minus 1. In defining F, it should be noted that F is greater than 1. If F is less than 1, we have to take F is equal to S2 squared by S1 squared. And degrees of freedom N2 minus 1, N1 minus 1. Conclusions. Accept null hypothesis if calculated value of F is less than the table value. Reject null hypothesis greater than table value. Example, from the following data test, if the difference between the variances is significant at 5% level of significance. Sum of squares of deviations from the mean. 84.1, 84.4, 102.6. Sample size first set 8, second set 10. Sample A and B. Solution. First take H naught, hypothesis, sigma 1 squared equal to sigma 2 squared. That means the samples are drawn from the population with equal variance. The alternative hypothesis, sigma 1 squared not equal to sigma 2 squared. That means the samples are drawn from the population with unequal variance. The variance of sample A is S1 squared equal to x bar the whole square divided by n1. The sum of squares of deviation from the mean 84.4, n1 that is 8. Variance of the sample B S2 squared, sum of you can say y minus y bar the whole square by n2, that is equal to 102.6 divided by 10. The estimated variance of population from which the sample A and B are drawn are given by S1 squared equal to N1 S1 squared by N1 minus 1. So N1 is 8 by 7 into S1 squared. S1 squared is 84.4 by 8. That is equal to 12.06. Capital S2 squared, N1 small, N2 small S2 the whole square by N2 minus 1. That is equal to N2. N2 is 10 by 9 into 102.6 by 10. That is equal to 11.4. Use calculator. So here S1 squared is greater than S2 squared. So F statistics is given by S1 squared by S2 squared. That is equal to 12.06 by 11.4. Use calculator. The answer is 1.058. Let's find the degrees of freedom. S1 is numerator, so N1 minus 1, comma N2 minus 1. N1 is 7, 8 minus 1, 7, 10 minus 1, 9. So table value of F test 7, 9 at 5% is 3.29. Conclusion, H0 is accepted since the calculated value of F is less than table value of F. Hence, the population variances are equal. Another example. Values of a variate in two samples are given below. Sample 1, 5, 6, 8, 1, 12, 4, 3, 9, 6, 10. Sample 2, 2, 3, 6, 8, 1, 10, 2, 8. Test the significance of the difference between the two sample mean. And the two sample variances. Here they ask test the significance of two difference between two sample mean and two sample variance. If two sample means, we use t-test. Sample variance, we can use f-test. Solution. Let us first calculate the mean and variance of the two sample. So sample 1, let us take x, that is 5, 6, 8, 1, 12, 4, 3, 9, 6, 10. So we need to find x squared, that is 25, 36, 64, 1, 144, 16, 9, 81, 36, 100. So n1 equal to 10, then x bar is equal to summation of x by n, summation of x 64 by 10, that is 6.4. We can find small s1 squared equal to summation of x squared by n1 minus summation of x by n1 the whole square. That is equal to 5112 by 10 minus 64 by 10 the whole square. That value is 10.24. Similarly, we can find sample 2. Let us assume y 2, 3, 6, 8, 1, 10, 2, 8. So y squared 4, 9, 36, 64, 1, 100, 4, 64. From this data we can find x bar and small s2 squared. So here n2 equal to 8 only. So y bar is equal to sum of y by n, that is 40 by 8, that value is 5. So s2 squared is sum of y squared by n2 minus sum of y by n2 the whole square, that is equal to 282 total by 8 minus 40 by 8 the whole square. Use calculator, we can find the value. The value is 10.25. But here they are asking two cases. One is difference between two sample mean and two sample variance. First case, case 1, test for mean. So here h0 mu1 equal to mu2, That means there is no significant difference between the mean of the two populations from which these samples are drawn. H1, mu1 not equal to mu2. That means there is a significant difference between the mean of the two populations from which these samples are drawn. The unbiased estimate of the population S squared equal to n1 s1 squared plus n2 s2 squared by n1 plus n2 minus 2, 10 into 10.24 plus 8 into 10.25 whole divided by 10 plus 8 minus 2 is calculator 11.525. So yes, test for t, x bar minus y bar divided by s into square root of 1 by n1 plus 1 by n2. 3.395 square root of 1 by 10 plus 1 by 8. Use calculator, we can get 0.87. Degrees of freedom, n1 plus n2 minus 2, 16. Table value of t for 16 at 5% level is 2.12. So H0 is accepted since calculated value of t is less than the table value. Therefore, the mean of the population are equal. But case 2, n1 equal to 10, n2 equal to 2, s1 squared equal to 10.24, s2 squared equal to 10.25. So null hypothesis H0 is equal to sigma 1 squared equal to sigma 2 squared. H1 alternative sigma 1 squared not equal to sigma 2 squared. Its population variance are equal. H1 variance are not equal. The estimated variance of the population capital S1 squared equal to small n1 s1 squared by n1 minus 1. .38 n2 s2 squared by n2 minus 1. So here s2 squared is greater than s1 squared. Therefore, the test statistics f is equal to s2 squared by s1 squared, and degrees of freedom n2 minus 1 comma n1 minus 1. Conclusion, H0 is accepted. 5% level since calculated value of f is less than table value of f. Therefore, the variance of the population are equal.